Hello and welcome back to another ContinuousX podcast where we try to solve for X in the SDLC equation. I'm your host, Mike Fitzurka, and today we welcome back our guest, Arthur Hicken, Chief Evangelist at Parasoft and fellow hat aficionado, which is a partner of ours that specializes in all manner of software testing. Welcome back, Arthur.
Hello, Michael. Glad to be here again.
As you well know, AI is just everywhere these days. Been so for about the whole year. Everyone's got a buzz around generative AI with art and chatbots. And there's even been a recent executive order on making sure that we keep AI secure for the future. And I've been deep into it. I think the hype is real and AI's possibilities are just enormous. And one of the most interesting trends I've seen, there's a lot that's coming up around this, is using large language models, LLMs, to generate code. And now that's coming after my job. But I think it's I think it's a good thing. We should all use. I've been using AI, and it's a great tool to enhance the process, but I wouldn't go so far as to suggest everyone fire their their programmers and get some good prompters, because you still need to evaluate the output. You still need to make sure that what it's creating is good beyond just running it. So I'm curious to kind of get your take on how AI and LLMs have been transforming our software industry and the development and testing process, and if you've got some best practices for our agencies that are looking to adopt these technologies, because I think everyone is.
It is certainly an extremely exciting time. I've had countless friends, family, and people I encounter ask me about, is AI going to take over? Is it going to rule the world? Is it going to kill us? Right? I subscribe to the belief that I'm not afraid of AI that passes the Turing test. I'm afraid of the AI that intentionally fails it.
I'm afraid of the person that's using the AI much more than the AI itself.
I always come back, I guess autonomous driving is one of the simple ones for most people to relate to. And you ask yourself, okay, is this software, is it better than the idiots that are driving out there? See, I can call them idiots. They're not our customers, right? Like I see this every day. They're terrible. People are terrible at driving, right? So I
not our audience, but we're good.
Can software do that? And then I think about the software people that I encounter, and some of them are amazingly good and some of them aren't. And then I ask myself, do I trust more the software engineers or the AI? And that's the question we haven't resolved. But I've thought for years that AI was going to sneak up on us. It's not predictable when you could say that an AI is good enough to replace a senior architect who can design and build software, right? We don't know when that day's coming. And when it comes, it'll be, oh, that happened yesterday, right? Like there'll be no warning.
Yeah.
And I think we passed one of those inflection levels now. I think that the most important thing to remember is that I always spell AI with a big A and a little I. Because it's very artificial and it's not very intelligent.
Yeah, I agree. Very hallucinogenic,
recall, right? Yeah. And we have to keep that in mind, because at the moment, with the capabilities that LLM brings, and they are shockingly interesting, if you think of AI as a person replacement, you're going to be very disappointed. And if you bet your business on it, you're going to be out of business.
Right.
If you think of AI as a tool in the toolbox that you empower your developers and testers with to let them get more done more quickly, or to do things that they were unable to do before, then you're going to be very, very pleased and very successful. And that's really the key, is keeping the AI in its box, okay?
Yeah.
Deploying it, checking it. but go to ChatGPT or any Bing whatever, and type in, asking it to summarize something that you care about, something that you're knowledgeable about, and do a quick read of what comes back. And you'll probably go, yeah, that's pretty good. And then step back and say, okay, now as a critical user and I was online looking for something, and you read it, and you might find that it's overly superficial, that it's maybe even inaccurate. And we've seen this in the coding even.
Okay.
Ideally, we're not there yet where we could do it, but if you were an organization that wanted to use AI for creating code, you'd want it trained on your coding styles and your coding practices and your coding behaviors, not on random open source of let's say software of unknown quality, right?
Right.
The FDA calls it software of unknown provenance. I'd call it projects of unknown provenance, because that acronym is better than soup.
Yeah.
But yeah, it's a little tricky right now, and if you wield it, in the hands of a professional, it's going to make your organization far more successful. I do feel like maybe testing is currently lower hanging fruit for people. I think it makes a better tester than a coder.
That's good, because I don't think coders make good testers. I think that coding is a creative process, and testing is a destructive one. How can I? It's like, I'm going to give birth to a baby. Now, how can I kill it? How can I make it not do what it's? I've tried so hard to make it do. It's a very different brain set, and it may be. I've used AI to code, but it's. I look at it as kind of paired programming. An old XP term that it's best not to let it do everything. You need to guide it, and then, or you just give it and say, here's what I got. What do you think? Or where do you see a flaw? And let it kind of test it. I like that, that concept. It's probably testing's a more rote, let me try this, let me try to break it down, that it might be better at. Yeah.
See, I've long thought of static code analysis as a form of pair programming. Right? Oh. And maybe it's how we built ours, because originally we built on Scott Meyer's work, Effective C++. Mm-hmm. If you've never read it, it's scared straight for programmers, because he had 50 different, he called them rules. And he would show you a piece of code that was innocuous and may exist in your application somewhere, and then he'd show you the conditions in which 2 + 2 would equal 5.
Oh, right.
And you'd go, oh my gosh. And that's the problem, that static analysis has the ability to tell you something that you don't know, like having a very senior advanced programmer tap you on the shoulder and say, Michael, I wouldn't do that way if I were you. I mean, it'll compile and it'll give you a right answer 8 times out of 10. Are you comfortable with 8 out of 10?
Right.
Or even 9 out of 10? Right. And so I think that, using AI to improve static analysis, to be able to find more things, to reduce the noise in static analysis. We've even added, like in our static analysis using LLM, we can explain why the violation is there, because again, the most valuable static analysis messages aren't the ones that you understood immediately. They're the ones that you went, that's not real, that doesn't matter, that's not important. Right. And you need that if you had a human, you'd be like, why should I care about that? And then it explains it to you in context of your code and your requirements. And then, well, how can I? Sometimes a fix is easy. And obviously computers have been doing quick fixes for 20 plus years, right? But an AI type fix, like here's how to remediate your code, requires some thought. And the LLM, if I know your code, and I know what code is supposed to look like, and then I can give you some examples if I know what's broken to lead you toward remediation. So we've made some really interesting leaps there. And I think that kind of an area where the LLM will help give you context, that it'll take over lightweight work that becomes heavier and heavier and heavier over time.
Sure.
Can we do test generation? Yes. Can we trust every test that got generated? Unequivocally, no.
Right.
Unequivocally, no. it'll get better over time. Are the tests all deep enough, interesting enough? Do the tests take into account business logic? No, we're not there yet, right? They're the stuff you would give junior programmers. So there you go, right?
Right.
But your junior programmers at work looking at what the AI generated, and now they're being trained by it. Now I have again the question: who trained the AI, and how good is it? But
well, you make a good point about if a static code analyzer, no one's going to fire all their junior developers because they've now got a static code analyzer, and this is just a slightly better version of that can generate some of the more low hanging fruit. And even as a senior programmer, it gave me new things to think about. Like when I was paired with it, it's like, okay, and that's valuable. It's a tool. And if you use it as a tool, and if our audience just starts to adapt and look at it as a tool, I think that's the right attitude to take with it right now. I trust a static code analysis. I'm not sure I'm there with LLMs yet. They do tend to hallucinate, but I'm always willing to take another input, another view at it, and say, okay, yeah, I didn't think about that. Let me look at that angle from whatever the LLM comes up with.
Yeah, and I think it is important to put its role properly, right? Because if you come in and tell a team, okay, we've got 5 AI bots that are going to generate tests, and we've got 5 humans, and we're gonna pit you against each other, Casey Jones style, and survival of the fittest, then they're going to sabotage your project, right?
Yeah.
Like, I mean, and they're not going to accept it well. They're not going to make the most benefit out of it, as opposed to, here's a tool designed to help you, instead of I'm going to replace you, I've given you a jackhammer. Now you don't. Right. Now you don't have to use a shovel. Your life is going to get better. And as we do that to engineers, the really interesting thing is that the smarter engineers are, the more quickly they get bored with what they're doing. So if we can lift the tedium off, right? We've had capabilities again for decades now that could generate shells of code, right? And generate shells of tests and start to generate some things inside of there. I mean, we've been doing unit test generation since the 90s, right? Like reading code, automatically generating unit tests. But being able to generate things that are more intelligent, and that leaves you free. Now you can go, let me be the breaker that I was born to be. Let me stop worrying about min length, max length, one more, max plus one, numbers in letters inputs, letters and number input. Let me stop generating all the tedious thing that the computer can quickly be given a prompt to develop. And now let me start thinking of truly insidious bad behaviors.
Right.
Free. And now, yeah, we've made your application more stable, more resilient, but we've also increased, improved developer and tester experience.
True.
They're not working on Tedium. They're no longer a factory line worker, right?
Right. And that's, I think, every developer I've ever talked to, that is what they want. They don't want, yet another, input, data object. So anything that can be done to help that, I think, is fantastic. So I think that should just about do it for today's episode. Again, I'd like to thank our guest, Arthur, for his glimpse into the AI testing generation, and specifically, again, our viewers and listeners for tuning in. Next time, we're going to expand on this theme. We're going to talk about AI test generation and something that's a fever dream of mine, self-healing test cases. Yes, you heard me right. So stay tuned as we continue to search for or solve for X in the SDLC equation.
Thanks so much for having me, and everybody good luck with not getting killed by your own AI.